Okay, so now we're going to find the area between e to the x and e to the 2x over the interval 0 to 1. Okay, so here we see we're given functions of x, so f of x's and g of x's. So that means that we're going to be integrating along the x-axis. Okay, so that means we're going to be using dx, and this interval here is our x interval. Okay, so now we need to determine what is our top function and what is our bottom function. So here are the blanks here, top and bottom. And so the way to figure that out is let's pick a point in our interval. Okay, so if we pick a point within our interval, let's say like 1/2 or something, so x equals 1/2, and we try out that point in our function. So we get e to the 1/2 for the first one, and then let's compare it to e to the 2 times 1/2. Okay, so this is where we're plugging it into the second function, and this is the first function. So how do these compare with each other? So here we have e to the 1/2, and then here we have e to the 1. So that means the right side is the greater function. Okay, so that means that e to the 2x is our top function, and e to the single x, so x to the 1 power, that is our bottom function. Okay, so now that we have this piece of information, that's all we really need, this box here. Okay, so we can set up our area integral. So area is going to be equal to the integral from 0 to 1 of top minus bottom, so that'd be e to the 2x minus an e to the x, and then our dx is there. Okay, so now what we're going to do is basically just go ahead and integrate, basically. So we're going to have a is equal to, and then we'll have an e to the 2x, and then we have to have that factor of 1 over k, so that would be 1 over 2, right? And then minus e to the x simply. So then we just are going to evaluate this from 0 to 1. Alright, so on the next line we're going to get a, when we plug in a 1, we get 1/2 times e to the 2 times 1 minus e to the 1 power. Okay, so that's when we plug in a 1, and then we have minus 1/2 e to the 2 times 0, so that's when we plug in a 0, and e to the 0 power. Okay, so these ones here, this is basically like e to the 0, e to the 0, and e to the 0, so this is a 1, and this is also going to be a 1. So at the end here, we're going to have a minus 1/2 minus 1, so that'll be, well, anyway, so I'll continue this on the next slide so we don't get too confused by me just talking randomly. So a is going to be equal to a 1/2 times e to the 2 times 1, so that's a 2, and then minus 1/2, well, no, okay, hold on, backing up, and then minus this e to the 1 power. Okay, and then we had this minus 1/2 times 1, and then a minus 1 as well. Okay, so now that we have this, we can continue along. So we have this e squared over 2, and then minus an e minus a 1/2, and plus a 1. Okay, so this is going to end up being a is equal to, and let's combine these two back here. So we just get e squared over 2 minus an e, and then this is plus 1/2. So this is the only oddball left out that doesn't have that common denominator. So we're going to make it fit. So we're going to say e squared minus 2e plus 1, and this is all over a 2. Okay, and this is a constant. E is an actual number, 2.71-ish. Okay, so this is the area between those two graphs.
De fé, na cidade suja, cinzenta, lotada de ambição. Durante suas tardes